let's evaluate this nice limit. We have the limit as x approaches infinity of the x root of x. So how can we evaluate a function of this form? Of course, we know that as x approaches infinity, if we substitute infinity here, we have infinity root of infinity, and of course that is undefined. But we know that this function x root of x can be written as x to the power of 1 over x. And same, if we still substitute infinity here, we are going to have infinity to the power of 1 over infinity. And this is still undefined. So we are going to be using the L'Hopital's rule here. But remember the L'Hopital's rule. We use the L'Hopital's rule for a function of single variable. But before we can use the L'Hopital's rule, we need a rational function. So we can actually express this function in terms of a rational function of this form. The limit as x approaches infinity of x to the 1 over x. But this is not still in the form of a rational function, so we can still evaluate again. But you know, we like e to be as the base, so we can actually write this as e to the ln of x to the power of 1 over x, because we know that e to the ln always cancels each other. For example, we have, if we have, let's say we have ln of 4, the natural log of 4. If we take the exponent of the natural log of 4, say e to the ln 4, you are going to have 4. So we have e to the ln of x to the power of 1 over x, because e we always cancel the natural log. Please take note, e we always cancel the natural log. So if this is true, this is not still in the form of a rational function, but we know that e is a continuous function. So we can actually write this as e to the limit as x approaches infinity, e to the limit as x approaches infinity of the ln of x to the power of 1 over x. But we know that 1 over x will come over, so we have e to the limit as x approaches infinity of 1 over x ln of x. So this is what we have. So we can write this as e to the limit as x approaches infinity of the ln of x over x. Now, if you observe, you will see now that this is a rational function, and the variable we have there is x. So we can actually apply the L'Hopital's rule now by differentiating the numerator and the denominator. So we have e to the limit as x approaches infinity of d dx of ln of x over d dx of x. So this is what we have. E to the limit as x approaches infinity of, if you differentiate ln of x, you have 1 over x. And if you should differentiate x, you have 1. So we can now go ahead and substitute our limits. So if we substitute our limits, we have e to the, if we substitute x approaches infinity, we have 1 over infinity over 1. And this is the same thing as saying e to the 1 over infinity. And 1 over infinity is 0. So we have e to the 0 power, and this is equal to 1. So therefore, the limit as x approaches infinity of the x root of x is equal to 1. So thank you for watching this very short video. Please, if you enjoyed this video, do well to subscribe. If you have not subscribed, subscribe and like this video if you enjoyed the video. See you in the next one. Thank you.